Welcome to Martin's Institute of Teaching. In this video, we're going to be working with differential equations, second order linear equations, and we're going to solve for the initial value. So in the previous two videos, we actually did problems similar to this, but we didn't have initial values. When we solve these, it's going to be exactly the same as the previous ones. Well, at least the first portion will be exactly the same. And then after that's when we actually deal with the initial values. So we're going to solve these problems. Let's jump in straight into number 9. So here we've got this equation. First thing we want to do is we want to solve for C1 and C2. So we're going to put this into the characteristic form. We're going to get r squared plus r minus 2 is equal to 0. And we're going to factor this out. R minus 2 plus 2 times r minus 1 is equal to 0. And if any portion of this doesn't make sense, I recommend you watch the previous two videos on this subject, and I explain how to go ahead and do all this. So now that we have this, we're going to get r is equal to, it's going to be equal to negative 2 and 1. Pumping these into the equation, we're going to get y of t, let's do that neatly. We're going to get y of t is equal to c1 e to the negative 2t plus c2 e to the t. Now, once we have the equation in this form, now what we need to do is start solving for c1 and c2. The way we do that is we're going to use these initial values that they gave us. So here, well, actually, let me bring it up higher. So here, we're going to say when t is equal to 0, we're going to put in 0 in for the t's. We're going to replace the t's with zeros. So you're going to get c1 e to the 0 plus c2 e to the 0. And that's just going to get, then we're going to place this y right here with 1. So you're going to get 1 is equal to c1 plus c2. So now that we have that, now we got to go on to the second portion to solve for the c2. So we're going to actually take the derivative of this, and so we can use this second initial condition. So here, taking the derivative of y, you're going to get y is equal to, and then we're going to bring down the negative 2. What you actually do is you're going to have the negative 2t. You're going to have to take the derivative of that times c1 e to the negative 2t plus, we're going to bring down the t, take the derivative of that times c2 e to the t. Here, we're going to take the derivative of negative 2t, and you're just going to get the derivative of y of t is equal to negative 2 c1 e to the negative 2t. This is just going to be plus, the derivative of t is just a constant, which is just going to be 1. So we're just going to get c2 e to the t. So now, let me scroll down a little bit. Okay, so now, actually, what did we get for that one? It's okay. So now, for this one, we want to plug in this this initial condition that we have, which the derivative of y is equal to 1. So now, plugging this into here, you're going to get, let's see, so when t is equal to 0, you're going to get negative 2 c1 e to the 0 plus c2 e to the 0. So the derivative of y, well, actually, let's go ahead and replace y prime with 1, and we're just going to get that's equal to negative 2 c1 plus c2. So now we can use these two, this portion, let me scroll up, we can use here, because 1 is going to be equal to c1 plus c2, and we can use 1 is equal to negative 2 c1 plus c2. So for this one, what I'm going to do is I'm just going to go ahead and shift the c2 over. So I'm going to say C1 is equal to 1 minus, 1 minus C2. And then I'm going to put this, and I'm going to plug it into this equation down here. I'm actually going to plug it in right for the C1. So let's go ahead and do that. Except I'm going to do it over here. So I'm going to say 1 is equal to negative 2. And then we're going to get, for C1, we're going to plug in this value, which is going to be 1. What happened? What the heck? Come on. So we're going to get, for C1, we're going to replace it with 1 minus C2. So you get negative 2 times 1 minus C2 plus C2. So we're plugging in C1, this C1, for this C1 right here. And that's what we get here. So once we do that, we're going to get 1 is equal to, multiply that in, you're going to get negative 2 plus 2C2 plus C2. And that is just going to give you, so continuing on with this, I'm going to move the negative 2 to this side, which is going to give me 3 is equal to 3C2. I'm going to divide that out, and I'm going to get C2 is equal to 1. And then I'm going to plug this C2 back into here or into here in order to solve for C1. But since C1's already in the form I like right here, I'm just going to plug it in straight into this. So I'm going to say C1 is equal to 1 minus 1. So in this situation, C1 is going to be equal to 0. So, whoops. So now I can actually finish off this this right here. I'm going to plug in C1 and C2, and that's going to be the solution. So we're going to get y of t is equal to C1 is 0. Since that's 0, that's going to go away. And I'm going to plug in 1 for C2 is just going to be equal to e to the t. And that will be the solution of the equation, of the differential equation. So let's go on to the next one. Here we have y double prime plus y prime plus 3y is equal to 0. So again, we're going to do the exact same thing. We're going to go ahead, find the characteristic equation, solve for the roots. That's going to give us our general solution with C1 and C2 in it. And then we're going to use the initial conditions to solve for C1 and C2. So let's go ahead and do that. Okay, so we're going to go ahead and put that as r squared plus 4r plus 3 is equal to 0. So now let's see, now we need to factor this out, so we're going to get r times r, that'll give us our r squared. Now something times something equal to 3, that's going to be 1 times 3 will give us that, so we can say plus 1 plus 3. R times r gives us r squared, r times 3 is r3, plus 1 times r, so that's going to be r4, and then 3 times 1 is just 3. So we've got our roots here. So r is going to be equal to negative 1 and negative 3. So our general solution is going to be y of t is equal to c1 e to the negative t plus c2 e to the negative 3t. Now, at this point, we can go ahead and start using these initial conditions. So first thing I'm going to do is I'm going to take the derivative, so I'm going to get y of t. Okay, so I'm going to get y prime. This is going to be equal to, here I'm going to take the derivative of negative t, of e to the negative t. That's just going to give me a negative c1 e to the negative t. Taking the derivative here, that's just going to be negative 3 c2 e to the negative 3t. So now I've got these two. Now I just need to plug in the value for when t is equal to 0, y will be equal to 2. So I'm going to go ahead and plug that in over here. So this is going to be y of 0 is equal to c1. Now all my t's are just going to be 0, so both of the e's are just going to go away. So I'm just going to get c1 plus c2. That's going to be equal to 2. And now I'm going to do the same thing here for this, the derivative of y. And I'm going to plug that in right there. So I'm going to get the derivative of y, and when t is equal to 0, so I'm going to plug in 0 for all my t's, so this e is going to go away, and this e is going to go away. It's just going to go become a 1, because negative 3 times 0 is just 0, then e to the 0 is just 1. So this is just going to be negative c1. This one's going to be just negative 3c2. Okay, so now this one's going to be equal to negative 1. And so for this one, I can just, I'm just going to make c1 in terms of c2. So this is going to be c1 is equal to 2 minus c2. And then I'm going to use this to plug it in for c1 here. When I do that, I'm going to get negative, so that's going to be 2 minus c2 minus 3c2 is equal to negative 1. So when I factor in this negative, I'm going to get negative 2 plus c2 minus 3c2 is equal to negative 1. I'm going to add 2 to this side and add 2 to this side, and I'm going to add the c2 to the c3, so I'm going to get negative 2 c2 is equal to plus 1, so c2 is then going to be equal to negative 1/2. Okay, and then I'm going to plug this c2 back into here in order to get c1. So I'm going to say c1, that's going to be equal to 2 minus c2. C2 is negative 1/2, so this is just going to be 2 plus 1/2. So I'm going to get c1 is equal to 2.5. Okay, so now we have c1 and c2. So now I can just plug both of these values back into this equation to actually get the values for y of t. So y of t is equal to 2.5 e to the negative t, and it's going to be plus c2, and c2 is negative, so this is going to be negative. Oops, what happened? Okay, what's going on? This is going to be negative 1/2, and then let's see, so this is e to the negative 3t. E to the negative 3t. And that is the solution for this problem. So this is 6y double prime minus 5y prime plus y is equal to 0. Let's go ahead and jump on this one. So again, let's go ahead and put this into the characteristic form. We're going to get 6r squared. Oops, I want this neat though. So 6r squared minus 5r plus 1 is equal to 0. So factoring this one out, you can use a quadratic equation or you can just straight factor this one. This actually factors into, well, we know that we're going to need an r here, and we know we're going to need an r here in order to get that r squared. So, but we also want two numbers that will multiply to 6 and that will add up to negative 5. So 2 and 3 fit this bill very nicely. So this is, but we want it also to be negative. So we're going to say, oh gosh, I didn't leave enough space. So we're going to call this negative, it could either be the negative 3 or the negative 2. It doesn't matter, so I'll just let this be the negative 3. And this will be negative 2. This is going to be plus 1, plus 1. So when we multiply negative 3r times negative 2r, you're going to get 6r squared. When we multiply this into the 1, that'll be a negative 3r. This into this, it's going to be a negative 2r. Those add both together to negative 5r. 1 times 1 is just 1. So that works out. Now we're going to get r This one right here is going to be negative 3r plus 1 is going to be equal to 0. So we're going to move over that, and we're going to get negative 3r is equal to negative 1. So r is going to be equal to 1/3, or r1 that is. And r2 over here, so negative 2r2, let's do my r1. That's just to differentiate them. So r2 here plus 1. Now same thing again, we're going to get negative 2r2 is equal to negative 1. r2 is going to be equal to 1/2. So now we're going to get, let's see, let's go ahead and write it up here. I'm going to say y of t is equal to, this is going to be c1, and then it's going to be e to the t divided by 3 plus c2 et divided by 2. And we just need to solve for c1 and c2. So here we're going to go ahead and take the derivative, and we're going to get the derivative of y of t is just going to be equal to, we're going to bring down that, so we're going to get 1/3 c1 e to the t3 plus c2, oh wait a minute, so we're going to take derivative of this, so that's just going to be a 1/2. So we're going to get 1/2 c2 e to the t divided by 2. And then we're just going to go ahead and plug in these values. So for the first one, so when when t is equal to 0, you're going to get 4, so that'll be 4. And you just plug in a 0 for all these values, for all the t's. That's just going to go to 1, and that'll go to 1. So you're going to get 4 is equal to c1 plus c2. Then I'm going to write c1 in terms of c2. So I'm going to get c2 is equal to, c1 is equal to 4 minus c2. Now let's go ahead and plug in y, or the initial condition, into y prime, and you're going to get, so here is equal to 0. So I'm going to get 0 is equal to, and I'm going to place 0 in for all the t's here. So that's going to give me 1/3 c1, and a 0 here is going to give me 1/2 c2. And now, since I have this, well, if I plug this c1 in here, I'm going to get the 0. Actually, let me move over. I'm going to get 0 is equal to 1/3, and it's going to get multiplied by 4 minus c2 plus 1/2 c2. So when that gets multiplied in, I'm going to get 4/3 minus 1/3 c2 plus 1/2 c2. Oh, whoops. Plus 1/2 of c2. So then I'm going to move the fourth, this is equal to 0. Running out of space, so let me scroll down a bit. So now, let's see, I'm going to get negative 4/3 is equal to, and I'm going to add those two together, so it's going to be 1/2 minus 1/3 of c2. So those two together, this is going to become a 3/6. That's going to become a negative 2/6. So that's going to be equal to, no, I need that parentheses still. Times c2. Okay, so now that's going to be negative 4/3 is equal to 1/6 c2. Now I'm going to multiply both sides by 6. So this times 6, this times, oops, well that is a 6, but that's not what I wanted. be 6 times this. So here 3 goes into 6 twice. So that's going to be negative 8. 6 times this is just going to be 1, so C2 is going to be equal to negative 8. Now I just need to plug this back into C1 to get C1. And I think C1, where is that at? What do I do with C1? Oh, there it is. So over here, C1 is equal to 4 minus C2. C2 is actually negative 8, so C1 is going to be equal to 4 minus 8, so that's going to be equal to 12. So C1 is equal to 12, C2 is equal to negative 8. And then we just plug in C1 and C2 and we finish this problem off. So our final solution is going to be y of t is equal to, actually what is y of t? So the first one will be 12 e to the, what was it? T divided by 3 plus, actually this is minus 8 e to the t divided by 2. And this is the solution to that problem. So, okay, now we got that one. Let's continue on to the next one. Now we're dealing with the second derivative of y plus 3 times the first derivative of y is equal to 0. And this one I'm hoping should be a lot quicker than the other ones. So again, let's put it into characteristic form. So first thing we're going to do is take out an r so we can factor this. So we're going to get r plus 3 is equal to 0. So r is going to be equal to 0 and negative 3. Now we're going to write that into the equation. So we're going to get y of t is equal to 0, so this is going to be c1 e to the 0 power plus c2 e to the negative 3t. So this yt just becomes yt is equal to c1 plus c2 e to the negative 3t. Now that we have it here, we're going to go ahead and take the derivative so we can start solving this problem. First derivative of t, immediately this c1 is going to go to 0 because the derivative of a constant is 0. So that's going to be 0 plus the derivative here, that's actually going to be a negative. So that'll be negative 3c2 e to the negative 3t. Let's go ahead and plug in for the y equation. So that's going to give us, let's see. So when t is equal to 0, we're going to plug in, well, there's nothing there, so it's just going to be c1. We're going to plug in 0 for t here, so that's going to give us just plus c2. And that's going to be equal to negative 2. Next one, we're going to plug in y, the derivative of y. So when y prime is 0, we're going to plug in, well, here that's already 0, so we're only going to plug in the 0 to here. So we're going to get negative 3c2 e, well, that's just going to be 1, so I'm not even going to bother writing it. And that's going to be equal to 3. So we get the value for c2 right away. c2 is just going to be equal to negative 1. And so that makes it really easy. We're going to plug this directly into this equation over here. So we're going to get c1 is going to be equal to negative 2 minus c2, plug negative c2, or plug c2 into here, and we're going to get c1 is going to be equal to negative 2 minus a minus 1, so that's going to be plus. c1 is going to be equal to negative 1. So now writing this out, we're going to get our final solution will be y of t is equal to C1, which is negative. So it's going to be a negative e to the t. Oh, actually, no. That's not it. I'm thinking, where is our actual, where we solved it? Oh, it's right here. No, it's this one. So our final solution is going to be e to the c1. c1 is a negative 1, so we're going to get negative 1 plus c2. c2 is negative 1, so it's going to be minus e to the negative 3t. And that's the final solution. Alright, great. Got through them all. So I'm hoping this made sense to you, and I hope it helped you out. If it did, fantastic. So the next videos are going to be, I think I'm just going to do a few more videos on initial value problems, or initial conditions, and then after that we'll go on to something else. So hope the video helped you out, and good luck in your classes. If you liked the video, please click like and subscribe.